Good evening kids, this is David, your faculty for electronics and robotics. So today we'll start our first class in electronics and robotics level 1. So before we start with the first class, let us recap what we learned in the previous session. In the previous session we learned what current and voltages is. So what is current? Current is the flow of electrons in a wire which is a conducting material. So then what is causing current? It is voltage. Voltage is the force required for the electrons to move in a wire, force that is causing current. So what is causing voltage? So voltage is caused by the attractive and repulsive forces of between charges. So this is causing voltage. So voltage is causing current. Now that the recap of the first session is completed, let's dive into the first class. Okay, now everyone take out your electronics and robotics kit and your breadboard and your worksheet. So turn your worksheets to page 1 of your electronics and robotics. The page should look like this. Has everyone opened your book to this page? Now we'll play a small sorting game. I'll give you 3 minutes during which you have to place each and every component in this electronics kit into its respective boxes in this page. So I'll show you one as an example. So now I'll show you a sample of what your activity will be like. You will take a component from your kit and place it to a place where you think the component belongs to. So I place the speaker in the speaker's place. Now you can look at each component, how it looks and how it looks in the picture here, and you can place where it belongs to. So now it's your turn. When I say start, you will start placing the components from your kit into its respective places on the paper. So your time starts now. Children, stop the sorting. Your time is up. So, how many of you are able to place all the components? Great. I know most of you were able to do it. So, now we will redo the same activity together and learn what each component is. This is a resistor. A resistor is a two-terminal device which reduces the flow of current. It is also used to divide voltage and it has other uses. Fixed resistors like this have fixed resistances which only change very slightly with changes in temperature and operating voltage. Variable resistors have changing resistances. They have a variety of resistances where you can select a specific resistance by pressing a button or changing a dial. The example for a variable resistor would be a potentiometer. The units of resistance is ohms and it is written as OHMS, or sometimes the value of resistance can be very high, such as 2 million ohms. As it is difficult to write 2 followed by 6 zeros every time, we use shortened notation such as mega ohms and kilo ohms. When you go out and buy vegetables, you might have heard the term kilo. Kilo means 1000 times more. For example, in measuring weights, 1 kg meaning 1 kilogram, that is 1000 grams. Similarly, 1 kilo ohm means it's 1000 ohms, and 1 mega ohm means it's 1 followed by 6 zeros ohms. So you know its value, and how do you measure it? The resistance of the component is measured by the colored strips that are on the resistor. Everyone can see the colored strips, right? The one I am holding has purple, gray and red. In the next class we will learn how you will find the value of each resistor based on the color coding that is there on it. So let's move to the next component. Now that you have learned what a resistor is, we'll put it in its respective place. You have a lot of resistors in your box. Put them all in the place of the resistor. So now that I have placed all my resistors in the box, let's move to the next component. The next component is the LED, or the light emitting diode. This is a light emitting diode. This is an LED. When current flows through an LED, it emits light. Here in your kit you have two different colors of LEDs. One LED is red in color, it glows red, and the other glows yellow. These two LEDs only allow current to flow only in one direction. If you put it in a wrong direction, the current won't flow through it and the LED wouldn't emit any light. The LEDs do not have any value measurable value. The LEDs have operating voltages. The operating voltages are voltage, the maximum voltage you can give to this component without destroying or damaging it. The operating voltage for an LED is 3.5 volts. You have a 9 volt battery in your kit. and the operating voltage for LED is 3.5 volts. So if you put a 9 volts voltage across a 3.5 volt LED, the LED will get damaged and get destroyed. So you will never connect a 3.5 volt LED to a 9 volt battery directly. You will use a resistor which acts as a voltage divider. So now you have learned how LEDs and what LEDs are and what its values are. So we'll place all our LEDs in the LED box. Okay, now that we have placed all our LEDs in the LED box, let's move to the next component. The next component is the capacitors. The capacitors are of two types, the ceramic capacitors and the electrolyte capacitors. The electrolyte capacitors have a circular housing. They are cylindrical in shape and have two terminals sticking out of them. Okay, these are electrolyte capacitors. You have 3 electrolyte capacitors in your kit. Place those 3 electrolyte capacitors in its electrolyte capacitors place. Next, coming to the ceramic capacitors. The ceramic capacitors have a grayish orange color. They have 2 terminals sticking out of them and they are circular in shape. Now we'll learn about what a capacitor is and why it is used. A capacitor is an energy storing component. They store the energy as electrical charge. When they are connected to a battery, these capacitors charge, and when a battery is disconnected, they discharge the stored energy into the circuit. These capacitors are normally used to prevent sudden changes in voltages. Normally, we measure capacitance in farads. As farads is a very big unit, we use microfarads or millifarads. The symbols for a capacitor's value, farads, is shown like this with an F, and a microfarad is shown as this, mu F. So now you can place your ceramic capacitors in its respective place. You have 2 ceramic capacitors in your kit. Place them in its respective box. Now let's move to the next component. Next component is a photocell. This is a photocell. Can everybody see that? Yes. A photocell, or it is also called an LDR, which stands for light dependent resistor. As the name suggests, it's a device. It's a resistive device whose resistance depends upon the light that is falling on it. Its resistance value changes when light falling on it increases or decreases. These photocells are used to sense changes in light. These can be used as light sensors in a lot of circuits. These are used in your mobile phones to set automatic brightness and in such applications. So now that you have learned what a photocell is, let's place it in its respective box. Now let's move on to the next component. The next component that we'll learn about is a speaker. A speaker is an electrical device which converts electrical signals into sound. These speakers are used in various different applications. They are used in your alarm clocks, they are used in your headphones, they are used in your home sound systems, and they have a lot of other applications. In your kit you have two types of speakers, one a regular speaker and one a buzzer. A buzzer, when connected, gives a set sound, meaning its sound that it produces does not change, while as the normal speaker, the sound it produces changes with the signal that is given to it. So now that you have learned what a speaker is, let's move on to the next component after we place these components in its respective place. So the next component. The next component is the silicon controlled rectifier. You can identify this component as it has three legs, as three terminals and a hole through its casing. This component is used to control current in a circuit. It has three terminals, namely anode, gate and cathode. Let's place it in its respective place and have a look at the next component. The next component is a diode. This is a diode. It has two terminals and has a black casing with a silver line on it. These diodes are used to restrict the flow of current into one direction, meaning these components only allows current to flow in one direction. When current tries to flow in the other direction, it does not allow it. Now, when you connect a diode in one direction in a circuit, it allows current, and when you connect it in a reverse direction, it does not allow current to flow through it. So that is the main property of a diode. And a diode, as it looks similar to a resistor, you can identify it by its characteristic black casing and a silver line attached at the end of it. So now that you have learned what a diode is, we'll place it in its respective place and move on to the next component. The next component is a transistor. A transistor is a semiconductor device that controls current in a circuit. It is a current controlled switch. It is used a lot. It is used in a lot of circuits such as amplifiers and smartphones. All digital devices that have a display and can perform some tasks have transistors in them. They are used in radios also. There are two types of transistors, NPN and PNP. You can identify these transistors based on the three terminals that are present on it and the engraving on the casing that is present. If you look closely on the case, you can find small printing on it giving the transistor code. As you can see, the transistor with the code BC548 on it is an NPN transistor, which is this. The NPN transistor has a characteristic bend on the sides. The side two terminals have a slight bend in them. So let's place the NPN transistor in its place. Coming to the PNP transistor, it has 188 printed on it. and it doesn't have any bends on any of its 3 terminals. So let's place this PNP transistor in its place, and let's continue to the next component. The next component is push to on switches. These switches are like the regular switches that you use in your everyday activities, but they are only on when you press them. When you release them, they turn to off. You have 2 such push switches in your kit. Place both of these switches in the push to on switch. So now that you have learned what a switch is, you place them in its respective place, let's move on to the next component. The next component is the potentiometer. This is a potentiometer. It has 3 terminals placed at the 3 different vertices of a triangular shape. This is a variable resistor. This has a resistance ranging from 10 ohms to 100 kilo ohms. You can vary the resistance of this component by twisting the dial that is on the white dial that is present on it. You can change the resistance, and this is also called a variable resistor. Now that you have learned what a potentiometer is, let's place it in its respective place and move on to the next component. The next component is the IC. ICs are also called integrated circuits or complex circuits packed in a small packing. As it is difficult to connect circuits with components as we use ICs. There are a lot of ICs with different applications and uses, but the IC that is present in your kit is called the 555 IC. This IC is used as a timer IC. It can be used to build blinking light circuits and other circuits. Let's place the IC in its respective place, and let's move on to the next component. The next component is the battery. A battery is a voltage source that runs on chemical reactions. It has positive and negative terminals. The batteries that are in your kit, the battery in your kit is 9-volt battery. To connect the battery to the circuit, we use a battery clip. A battery clip is also present in your kit. It has 2 connecting points and 2 output wires. The positive wire is given in red color and the negative wire is given in black color. You can connect the battery to the clip in this manner, and they clip together. So let's place both these components in their respective places in our worksheet. So with this, friends, we have completed sorting the components that are present in it. Apart from the components that we have just learnt about, you have 2 other components. The 2 other components are the wires that are used to connect the components together and the breadboard on which we make these connections. We can connect these components without a breadboard also, but it is a lot difficult. To make it a lot easier, we use a breadboard to make the connections. In the next class, you will learn how to use a breadboard and how to make those connections and make your first LED glow. Okay children, in this class we have learned to identify the components in your kits and we learned what each component's measurements are and where and how they are used. In the next class we will learn in depth of how and why we use a resistor, where it is used, and we'll build our very first circuit. So see you in the next class.